This is part of the Pond Basics playlist. We've already talked about pond position, types of containers or liners that are suitable for ponds and filtration. So this week let's talk about pumps. There'll be a link in the description if you want to watch the playlist from the start. In this video I want to talk about if you even need a pump, what type of pump, pump efficiency, moving the water with a clear objective, the pump position, plumbing, and anything else that pops in my head as I waffle on. So let's get into it. If you don't already know me, my name is Kev, and the aim of my channel is to help people build and maintain ponds without spending a fortune. If that sounds like something that interests you, feel free to subscribe and check out my website, ozponds.com. So do you even need a pump? Well, that depends on the type of pond you're setting up. As we discussed in the previous video, the amount of filtration needed is directly correlated to the amount of nitrogen the pond is producing. And we have two common ways to process the nitrogen: plants and bacteria. There is, however, a third, and that's doing water changes. For example, this bucket has some small rice fish I bred last summer. There's some sponge down the bottom and a small amount of plants. The water's clear and the fish are happy. There's no moving water. The sponge provides some additional surface area for bacteria. The plants consume some of the nitrogen directly, but probably the biggest reason that this is staying so clean and clear is that it gets water changes. I'm lazy and I just top the water up when I notice it's getting low. But the dog loves drinking out of these buckets, so even though I'm just topping up, the dog is helping me do a water change. This wine barrel pond has no pump. Again, it's got rice fish, lots of plants. In spring and summer, when the plants are growing faster, there's very little algae. During the winter, the algae comes along to help filter the water. So those are just two different examples of filtering water without a pump, one with plants and one predominantly with water changes. Both could be scaled up for larger bodies of water. For example, if you have a clean spring, it might provide enough water that you could constantly water change a large pond. You can have a large planted pond also. Just be aware that it can be hard to process enough nitrogen during winter when the plants are dormant, and during that time you may experience quite a bit of algae. You also need lots and lots of plants, and the more diverse, the better. There's some interesting examples of no pump swim ponds in Austria. No plants, just pebble providing surface area for bacteria. It's all very fascinating, and I'll leave a link in the description for anyone that wants to learn more. These swim ponds have no fish, so the nitrogen inside the pond is very low. Remember, the more nitrogen, the more filtration you need. So while it's possible to filter a pond and keep the water clear with small amounts of fish or no fish, it's not ideal for someone looking to keep a bunch of fish or turtles or even ducks. In my opinion, the easiest way to create a clear and healthy aquatic environment is to move water through surfaces that are colonised by the bacteria that process the nitrogen. And to do that, the easiest way is with a pump. And for anyone starting out, the easiest type of pump for a pond is a submersible pump. This is a pump that, as the name suggests, is submersed in the water. If you're building a pond to swim in, you might want to look into external pumps or air pumps. Submersible pumps can be regular voltage. That's the same as your house runs on, so they just plug into a regular power point and off you go. They can also be low volt. These have a transformer that take the regular voltage of your house power and convert it to a lower voltage. Many people, including me, feel safer with low volt submersible pumps. You can also get submersible pumps that will run on solar, either connected directly to a panel or a battery. These pumps are low volt DC pumps. And you can also collect regular voltage pumps to solar if you use an inverter to convert the DC power to AC. But that's a more in-depth video than this video aims to be. The beauty of a submersible pump is that they can be quite efficient and still provide a good amount of pressure which is handy for moving water through filters, creating streams and waterfalls, or even just pushing water around the pond via jets to keep things cleaner. When you're shopping for a pond pump, you want to pay close attention to how efficient it is. Every pump will tell you how many watts it consumes per hour. The lower the watts, the less it will cost you in electricity. My aim is to move the desired amount of water through the filter for the lowest possible cost. As I mentioned in the previous video, there's so many ways that a pond can be filtered. My personal favourite is using a bog filter. I've got plenty of videos on pond filters, so I won't start rabbiting on about them here. Before you buy a pump or pumps, it's important to know what your objectives are and what sort of filter you'll be using. For example, this pond with a bog filter for some goldfish, it's only running a 600 litre per hour pump. Whereas this waterfall filter is running 12,000 litres per hour. That's a big difference in the cost to buy the pumps, but also to run them continuously. If you want to have jets to push water around or to keep the pebbles clean, you'll need more flow. If you want a tall, wide waterfall, you'll need more flow and a higher head capability. All pumps will have a head height graph or a table, and this will show you how the higher you pump water above the surface of the pond, the more the flow decreases. So these are all important factors to consider. I have other videos that go into more details about different filters, flow rates for streams, waterfalls, sizing the plumbing, etc. But because every pond is different, with different methods of filtration, the flow rate requirements vary so much, it's hard to give a really good overview guide. My PDF on the website is a good overview guide if you want to use a bog filter. So again, before you buy a pump, have a really clear idea on the type of filter or filters you'll be using. There's no point in having an oversized pump that costs you more to run than it needs to, and there's no point having not enough flow that you can't achieve the stream or waterfall that you were hoping to have. Now let's take a look at where to position the pump. If you want to create a skimming effect on the surface of the pond, you can do this in 3 ways. The first is a skimmer. There's skimmers that sit inside the pond or float around in the pond, and the pump is connected to these. There's also skimmer boxes, and the pump sits inside here, drawing water in and then pumping it off to the filters. There's intake bays. These are supersized skimmers, and they're great for ponds with lots of leaf material falling in. A small skimmer can quickly clog with lots of leaf material, whereas a properly sized intake bay won't really clog at all. Then there's a negative edge. This is where the pond overflows into a basin. The pump sits inside the basin and pumps the water back to the filter. It's a good idea to position the skimmer, intake bay or negative edge basin on the opposite side of the pond from where it flows in. This will help improve the overall circulation of the pond. Skimmers, intake bays and negative edges all provide an element of mechanical filtration, and that can greatly reduce how often you need to check the pump to make sure nothing's clogged. Sometimes it's desirable to have the pump inside the pond on the bottom. If you really want to keep the bottom clean, you can use a solids handling pump that is designed to pass larger solids back to the filter. You could also use a bottom drain that the pump is connected to, or a suction grid. A suction grid can be run using an aerator. It's like a supersized aquarium undergravel filter. Both are viable options worth looking into if a clean pond bottom is a priority. When I place a pump inside the pond, I like to keep it slightly raised up off the bottom. This is just in case the plumbing bursts or gets a hole, the entire pond won't empty. When it comes to connecting the pump and the filters, it's like everything, they're all different. Don't overthink it. All you need to do is move the water from the pond into the filter. I just use the largest size pipe or tubing that the pump fittings allow. You can use flexible hose or rigid. If you use rigid, try and reduce the amount of elbow fittings if a good amount of flow is a priority. There's really so many different configurations. The images on the screen are just some of the different ways, pipes and connectors that I've used to connect my pumps to the filters. Remember, all that's important is getting water from A to B. Wherever possible, I prefer to keep my pipe or tubing inside the pond. Again, this is if a plumbing line bursts or a connection comes loose, the water will remain inside the pond. So in summary, when selecting a pump, think about the amount of flow you need, the head height required, and the amount of energy it will consume. I'll link some low volt sine wave pumps in the description that I personally like to use. There's lots more of these pumps hitting the market now, which is great to see. I hope this video was helpful. If you have any questions, throw them down in the comments and I'll do my best to answer them. Thanks for watching. See ya.